Good afternoon, guys. Today we are going to be talking about systems of linear inequalities. Okay, we have just some general rules to follow when it comes to systems of inequalities. When we are graphing them, we want you to graph both inequalities. Using the slope and y-intercept, plot 2 points that will be on the line. Put in slope-intercept form first if needed. Okay? Step 2, determine if the line should be dashed or dotted or solid, and draw a line to connect the points. Step 3 is going to be shade either above or below the line. And then step 4, a solution will be any point that is included where the shading overlaps. Remember, it is not included on dashed lines. Okay? So a solution will not be on a dashed line, and it will also be where the shading overlaps for both inequalities. So let's just go ahead and take a look. Okay? If we look at the first one, y is less than 3x plus 2. Okay? We know that my slope is 3 and my y-intercept is 2, so I'm going to put a point on 2. My slope is 3, so I'm going to go up 3 over 1. I'm going to put a point there. I'm going to go up 3 over 1 more. Then I'm going to come down here. I can go down 3 and to the left 1 if I need to. The more points you use, the more accurate your graph is, right? All right, now let's take a look at my inequality. It's y is less than. We know because it's just less than and not less than or equal to, I'm going to have a dashed line. Okay? And it's going to look something like this. And because y is less than, we are going to shade below it. Okay? Now, for our second equation, I'm going to use red to graph it. It's y is greater than or equal to negative 2x minus 4. My y-intercept is negative 4, so I'm going to come down to negative 4. 1, 2, 3, 4, and I'm going to put a point there. Okay, my slope is negative 2, so I know I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and then I'm going to go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Here, I know it's greater than or equal to, so I'm going to have a solid line because it's greater than or equal to. Okay? And it's greater than, which means I'm going to shade above it. Okay, so all of this area above that line. Okay? So our solution is going to be all the points that are included where the shading overlaps. So this area right here is going to be our solution area. Okay? Our solution can be included on the red line, but not on the pink line. The pink line is dotted, so it is not a part of the solution. The red line is solid, so it is a part of the solution. Okay? Let's go ahead and take a look at another example. Here I have y is greater than 7. Okay. We know that this is going to be a special type of line, right? We know I'm going to go y is greater than 7. We know if I had y equals 7, it would be a horizontal line, right? So, I know it's going to be a dotted line. I'm going to cross the y-axis at 7. So that is right here. We know it is just going to be a vertical line. We know it's going to be a dashed line. So I'm going to draw myself a dashed or dotted line, whichever word you want to use. And it's greater than. So we know it's going to be all this area above the blue dotted line. Okay? Looking at the next one, it is x is less than or equal to 4. Or 4 is less than or equal to x. I'm sorry. So x is actually greater than or equal to 4. Okay? So I'm going to come over here on the x-axis. We know when we have x is equal to a value, it's a vertical line, right? So I'm going to come over here on 4 on the x-axis, okay? And I'm just going to have a vertical line, and it's a solid line because it is greater than or equal to. And if it helps you out to rewrite it with the x first, that's okay. It would just look like this. X is greater than. Okay? So, since it is greater than, we know it's going to be all values greater than 4. So, it's going to be all of this area. And our solution is going to be where the two overlap. So, this area, including the pink line, but not including the blue line. Okay? Right? If we, give me just a second. If we take a look at this next example, it says, write the system of inequalities from the graph. Okay, so let's take a look at each inequality. Okay, so if we take a look at the dashed one, the dotted one, okay, we're just going to call that one line A, and that's the one we're going to do first. We need to identify some information about that graph. We can see its y-intercept is at positive 4. We know it has a positive slope. And if you look at that slope, it is up 1 over 1, okay? All right, so for A, my y-intercept, my B, is 4, and my slope is 1. So, I need to come over here, and I'm going to leave a space for my inequality sign. And my slope is 1, so I can just write x, 1x or x, plus 4. Okay? It's shaded below, so we know y is less than our equation. And it's a dotted line, so it is just less than. We don't need to put the line. Okay? Now let's look at the next equation. I'm just going to call that equation B. It's a little bit harder to see where this equation crosses through the y-axis, but we're going to say it's right here at 1. Okay? All right, so my y-intercept is 1 for my equation B, and my slope is another pretty point, looks to be I need to look at it. I can't hardly see. Okay, a pretty point is right there. So, okay, our pretty point is right here. So if we go up, all right, our pretty point here is right here. If we go up 4 and over 1, we will be back to our y-intercept. So our slope is going to be 4, okay? So we come over here, we start writing our equation, y. We know my slope is 4. I'm going to leave my space for my inequality sign, so 4x, and my y-intercept is plus 1. We know my area for the solid line, it's shaded above it, so it's going to be greater than, and because it is a solid line, it's going to be greater than or equal to. And so there is our system of inequalities from the graph. And we are done for today, guys. Have a great day.